Hi, everybody. We're back talking about filtering joins. And so we've gone through and we've talked about mutating joins a bunch. I guess to recap, in the last video, we introduced what relational data was. We introduced the idea of a relation, a key, so on and so forth, and why that was important. And then we talked about mutating joins. Now we're moving on to filtering joins, and then we're going to talk about non-equid keys or non-equid joins. So far, we'll get there, so I won't go down that rabbit hole yet. So for filtering joins, there are two of them: semi-join and anti-join. So, or anti-join, however you want to say it. So semi or semi-join keeps all observations in X that have a match in Y, and then anti-join or anti-join drops all of observations in X that have a match in Y. So maybe I want to find the ones that don't have a match. So they are opposites in a sense. So here are some examples. So if I look at semi-join of X and Y, I only want the variables in X that have a match in Y. Notice I'm not smushing them together. So this is new behavior, not mutating. I'm not smushing data sets together. I just want to find observations in X that have a match in Y, because that tells me something. So for instance, I could be interested in how students are progressing through something that I might look at in the math department, or how are students who are in a remedial class, math, progressing on. And so I want to find the ones that did progress on. So a remedial math class that you might take when coming into Shippensburg is 117A, Applied Statistics. Okay, and so you come in and you take applied statistics with some algebra support, and then your next step to move on, if you are moving your way on to calculus, would be 140A, which is college algebra. So you do this path. Maybe I want to find the students in college algebra who were in a certain section of applied stats, or in applied stats in general. I have those two data sets. They have relations which are like a student ID number, and so I could semi-join them to see who are in both. Conversely, if I wanted to see the ones that went right into 140A and didn't come from 117, I could do anti-join or anti-join. So I think hopefully that made sense. So that's semi-join and anti-join. There are a few other interesting ones that aren't used so often, but you can do, in this relational sense, set operations. So there's an intersect, a union, and a set diff. So intersect returns only observations in both X and Y. Union returns unique observations in X and Y, and then set diff returns observations in X but not in Y. So similar things to what we've done, but more set operations that you might have seen in a discrete math course or something like that. And now we get to the newish stuff. I say newish because it existed before, but I guess it's newish to being taught in this class because this is new, and the join by argument, which I mentioned in the last video, makes the expression of these joins much more easy, and maybe doable at all. So far we've only seen equijoins, which is where the rows match if the X key is the same as the Y key. So either X, either one existed in X and one existed in Y, or 2 or 3 for my examples that I show. But what if I wanted to do not just equal to, but less than, greater than, not equal to? So something like that. We've done not equal to, anti-join sort of thing. But we can be more expressive. We can do more. And so there are 4 different types of non-equijoins that our book talks about. And so those are cross joins, inequality joins, rolling joins, and overlapping joins. So a cross join matches every pair of rows. Okay? no matter if they have a match, if they don't have a match, if they're not matched at all, so on and so forth. It just matches everything. Okay, and so that might be advantageous in some case. And then you have the inequality joins, which are, instead of using equals, if they are the same, maybe they're less than, maybe they're greater than, so on and so forth. So maybe I'm looking at something, at data over years, and I want to match them, to join them based on those years. And the years might change, and so on and so forth. And so I want to match everything before 1987 or after 2005, because there was some really big change that happened that now I want to explore in my data analysis. Okay, so those are the joins. So cross joins match every pair. Inequality joins use those inequalities. Rolling joins are similar to inequality joins, but only find the closest match. And so we'll see what that is. And then overlapping joins are a special type of inequality join designed to work with ranges. So like between kind of stuff. Right? And so here's the graphics, again, the fancy graphics for each of them. So the cross join is just gonna, it's matching all of them, no matter if they are equal or not. It's just matching them. Inequality join, so for instance up there, if my joins are, or my keys are my key column was the 1, 2, and 3. And so if I say join by key in the left is less than or equal, sorry, just less than, key in the left is less than key in the right. Okay, so if I look on the left, the first table, and the first row, the key is 1, or the value of the key column is 1, and so that matches to anything that is less than the key column in the second data set. And so 1 is less than 3, so it's matched. 1 is less than 2, so it's matched. 1 is not less than 1, so it's not matched. And so on and so forth. So that was the top 2 dots. The third dot, 2 is less than 3, so it's matched, so on and so forth. Okay. The rolling join, closest. So closest key is less than or equal to key. And so it's only going to do the closest one. So you'll see that you have black dots, which are the closest ones, and then you have the gray dots, which technically match the key but aren't the closest. So the keys say key is less than or equal to key. So is 1 less than or equal to 1? Yes. Is 1 less than or equal to 2? Yes. Okay, so on and so forth. Okay, but what's closest? So, or rather, it goes going the sort of the other way. But what's closest? Well, 1 is closest to 1, 2 is closest to 2, and then you get the interesting behavior here of 3 and then 4. So you have 3 and 4, which aren't quite a match, but so 3 is. So 1 is less than 3, 2 is less than 3, but 4 is not less than 3. And so we're dealing with the third row of the rolling join thing is where I'm looking at the moment. And so 3 is greater than equal to 2 and 1, but what is it closest to? It's closest to the 2, and so that's the one that gets it. Okay, and then you have overlapping joins, and so I put a number of the helper functions that you can use within join by. You see one of them up above is closest. Okay, and then you have the overlap one, so between, within, and overlaps, and so those might be examples that you use within a join by specification to do these non-equijoins. And so that's the end of the slides. And so let me move quickly over here to the New York City flights example. So I've previously run these 2 lines, so or rather I need to run this one. So I've loaded the NYC flights 13 package. If you look at NYC flights, you'll see that it has 5 data sets in it: airlines, airports, flights, planes, and weather, which we saw before. And so you can do various things with them. So, and all of this code is in the book, in the new book that just came out for R for Data Science. But I'll also give you this R file that you can run and follow along with. But I'm sorry, I need to add a third thing here, which is the tidyverse, because I'm going to use some other dplyr functions. And so here's the select function that you learned about. It's selecting only the important columns that I want. Okay, and so here are some examples of using a natural join, which means I don't specify what the key is in the first data set or the second data set. So I'm trying to match my new data set that I made up here, flights 2, with airlines. So I just want to add some airline information to the flights. And so when I run this code, it gives you some information up here. And so it says joining with this, join by carrier. And so what that means is that the only thing that matched in flights 2 and airlines, if we look at airlines, it's a simple data set that just has the carrier and the name of the carrier. So it has the code and the name. And so you can also see in flights 2, it's got lots of things, but one of them down here is carrier, and it's the same thing. So if you don't specify anything, it's going to find whatever it can. The only thing it found was carrier, and so that's what it joined by. Okay, now I have weather down here, so I'm taking flights here. I'm simplifying weather by selecting origin, time, hour, temp, and wind speed. Okay, and I'm joining the two together. Excuse me. So again, now it sees 2 things. So there were 2 things in weather, origin and time hour, that existed in both data sets, and so it's going to use that. So it's going to match them both. Okay, now, so those were just natural joins, me not specifying anything. And now down here in these 3 examples, I have three different ones here that use specifications use join by for specification. So now I have airports, okay, airports, and I'm using semi-join, so I'm finding airports that exist in flights 2, okay, and I want to join by, well, actually for this example, I have two things that I could join by. So if you look in airports, what you have is the FAA code, okay, and then in flights 2, there are 2 different variables. Variables, both the origin and the destination, that have the FAA 3-letter flight codes. Okay, now these are sort of weird, but there are these are weird ones. These are usual ones. Okay, and so I can join by origin or destination, and so I've done sort of both here. And so semi-join gets us airports that show up as the origin. So, there are only 3 of them. In New York, Newark, Liberty, JFK, and LaGuardia. And so they of course show up. Okay. Now I want to find rows that are missing from airports by looking for flights that don't have a matching destination airport. And so we can do that with this code. So now I have an anti-join, and now I'm looking for destinations. And so we find 4 of them there. And I could also do something like find which tail numbers are missing from planes. And this is another sort of anti-join. Now, These are examples where my keys don't match up, and so I have to do something like this. Down here, my keys match up. Both are called tail numbers, and so when I just say join by tail number, that means that they're the same in both data sets. Okay, and so I can shorthand it like this, or you could write it if you wanted to like this. They are the same. Okay, but that's shorthand for it. Now, I don't have examples here of the non-equid joins, but there are a fair amount in the book if you'd like to see them. Most of the joins that we'll work with in this class are the simpler joins that are the left join, the right join, the center join, and they're all equid joins. We're looking for equality. Okay, and so if I ask for a non-equid join, I will give the what I think is the proper sort of ground, the scaffolding for you to use them. Okay, and so that's the end of this video on joins. Hopefully it helped.